Welcome to this module of our Enterprise AI Masterclass. Today, our objective is to move past the basic chat interface and build a production-ready system. Many developers fall into the over-provisioning trap. They assign a single, highly capable and expensive model to handle every single step of a project. Relying on a single agent monoculture drives up your API costs by as much as 5 times. At the same time, it bottlenecks execution and drastically slows down your output. To scale your productivity and hardwire security into your workflows, you need to evolve from a solitary chatbot to a coordinated multi-agent architecture. Go ahead and open your preferred agent framework workspace. Immediately discard the generic default developer agent profile. We are building a team of specialists. Create your first role, the coordinator. Next, set up the implementer. Then create the navigator. Finally, build the auditor. Do not assign the same foundational model to all 4 of these new profiles. Doing so recreates the exact bottleneck we just dismantled. Let's set up the routing. For the coordinator, assign Claude Opus 4.7. You need its deep reasoning capacity for architectural planning and task decomposition. For the implementer, assign Claude Sonnet 4.6. It is optimized for fast, high-volume code generation. For the navigator, assign Claude Haiku 4.5. File searching and folder scanning require speed, and this gives you ultra-fast retrieval at a fraction of the cost. Look at this bar chart comparing deployment costs. The tall bar shows the high cost of a uniform Opus deployment, while the lower bar shows our multi-agent routing. By splitting the work, we achieve a 51% reduction in API costs. Matching model intelligence directly to task complexity is the core principle that makes AI economically viable at an enterprise scale. Now we have our specialists, but they are isolated. We need to connect them into an automated sequential pipeline. This vector flowchart maps our new path. Your prompt enters the coordinator node, branches to the navigator for retrieval, and passes context to the implementer. Submit Build a login page, and the coordinator decomposes that request into subtasks, passing them down the chain automatically. True orchestration shifts your job from writing individual lines of code to managing these autonomous task handoffs. Allowing an AI to autonomously commit code or delete files without oversight introduces a massive security vulnerability. This is where our 4th agent profile comes in, the auditor. Assign a highly capable reasoning model, such as GPT 5.2 or Opus, to this specific role. The auditor has one strict responsibility. It scans the implementer's generated code for prompt injection risks and vulnerabilities before deployment. To make this work, you must establish an absolute security mandate. The system is never allowed to self-deploy. Open your framework settings and activate the toggle for human confirmation for destructive actions. Now, the AI writes and audits the code, but the entire pipeline halts just before execution to await your approval. When the system pauses, you will face a prompt exactly like this one. It asks you to explicitly approve or reject the modification of a file, like auth.ts. This mandatory human-in-the-loop checkpoint is the defining difference between a toy AI experiment and a safe, enterprise-grade deployment. You have successfully evolved your setup from a basic chat interface into a secure, multi-agent orchestration engine. This split-screen diagram highlights your transformation. On the left, the old single-agent system flashes red, bottlenecking your data. On the right, data flows continuously across your new 4-tier pipeline, secured by a final approval gate. Your orchestrated system now successfully mimics the planning, executing, and auditing phases of a real engineering team. Click the link to the next module in the 3-hour masterclass, where we will connect this new team to your proprietary company data.